Hello, for data communications and network 1 class today, Ajahn Usana will teach about how to correct errors, okay? Only simple error pattern, okay, for this class. So we look at the definition of the error correcting code first. For single error correcting code, okay, this code must be able to correct all single error patterns. Now, what are the single error pattern? If you have like 7-fold code, okay, or NK code, okay, the error patterns, okay, will look like this, okay. So this is for 7-4, so we have n bit, okay, here, and it can be single error look like this, okay. These are all single error, okay, until 1 and all 0, okay. So you have NK code, okay, we will have n bit, okay, for the E, right? So then we have N single error pattern also. Okay. Okay. Now, so these are all the single error pattern that you must be able to correct, okay, in order to be called single error correcting code. How about double error correcting code? For this code, you must be able to correct all single and all double error patterns. Now, what are the double error patterns? Okay, so which means that you have two errors. For example, you have errors, two errors here, or like this, or like this. You can also have like error here, but you can have error, you know, anywhere, okay. You can have error here like this, okay. So you can have any combination, okay, of 2 bits errors, okay, and they are all called double error patterns. So there are many more double error patterns than the single error pattern, so this is more difficult to do and we will not be covered in this class. If you're interested, as I said, there's another class, apply coding next semester, okay. I actually have video for that class, but it's in Thai, sorry. Now we have the triple error correcting codes, okay. For this one, we must be able to correct all single, all double, and all triple error patterns, okay. What is triple error patterns? Triple error is the same in the similar manner, okay. Triple error patterns mean you have like 3 errors somewhere, okay. So anywhere you have 3 errors, okay. So any combinations of 3 bits that are errors, okay, are called triple error patterns. So you have to be able to correct all single or double and all triple errors. Is very difficult to do compared to the single error patterns, okay. And in this slide, you just cover the single error patterns. The Hamming codes that I use all the times, they are single error correcting codes, okay. And this is a 7-fold code. We have also 1511 code, which is also Hamming code. All Hamming codes based on the name of Kun Hamming, of Mr. Hamming. They are all single error pattern, single error correcting codes, okay. You can see that you have like n minus k equal to 3 here, n minus k equal to 4 here. Now, for the double error patterns, triple error patterns, or quadruple, whatever, okay, and more, okay, we can use BCH code. BCH code is based on 3 names, okay, abbreviation of 3 names. You can decide how many bits you want to be able to correct, okay. For this code, so it's very convenient. The single error correcting code for BCH is the same as Hamming. For double error patterns, you have 15-7. 15-7, you have n minus k equal to 8. You have 31-21, which n minus k equal to 10. For the triple error correcting codes, okay, of BCH, you have 15-5, which is n minus k equal to 10. 31 16 n minus k equal to 15, okay, and so on and so forth. Okay, now let's look at the method to correct single errors. Okay, first we will construct the chip register circuit, okay, based on GX. We have done this before for encoder and decoder circuit. Okay, we will use the decoder circuit to construct the syndrome table. Okay, anyway, so we input the error patterns or error vector E, which has n bits, okay, into the circuit based on the decoder. Okay, so we input on the left hand side, and we input with 1 bit of 1, okay, and then all zeros. This 1 bit of 1 is the most significant bit. Okay, we shift until the last bit of E, then we'll get the syndrome tables, okay, with the result from all chips, okay, and which I will show you in example in the next slide. But basically, result from the first shift after the first bit come in is the syndrome for these error patterns, okay, with again, this is most significant bit, and this is the least significant bit. So error in the least significant bit. Okay, the second shift, okay, second move here, n shift is moved here. Okay, so this is the error patterns. Why this work? Okay, please ask me outside. I mean in class. Okay, if you come in, please ask later. Okay, as I have to explain a little bit more on this, and I try to make it short videos. Okay. Anyway, construct the syndrome tables. How to do this? So examples, I give you NK codes, okay, with the GX of this, and you want to find the syndrome table. So we have the circuit, okay, this is the decoding circuit, and we input the E here with the most significant bit here. Okay, and we have 7 bit for the 7-fold code, right? And we initialize with the all 0 here. Then I have to be careful when we have feedback here. Okay, so at first the first 3 bit will be like shift with, you know, the shift will be all 0, okay, for the feedback, right? So actually I can just put it here, so it's 0 come in and plus 1 and become 1. Okay, we'll go a little bit quickly. You can check from your last video, okay, about how to decode with the chip register. It's the same. Okay, so basically I get this. Now I have to be careful. Feedback become 1. If the feedback become 1 here, it can go down 1 here and 1 here. Input is 0, right? 1 plus 0 is 1, right? And then sorry, okay, okay, so 1 plus 0 is 1, and then this 1 plus 0 is 1, this is 0. Now it's 0, so it's the same, just shift, right? Okay, then it's become 1. Now be careful again. 1 plus 0 is 1, 0 plus 1 is 1, this is the shift, again shift is 1, so 1 plus 0 is 1. This is this has to change, right? 1 plus 1 is 0, this is just shift. Okay, so this is the most significant bit. Be careful that because this is x to the cube here, most of it is on the right. Usually we use only the last shift, okay, as the result, right, the syndrome. Okay, but for this case we use all results, okay, to construct the syndrome table. So this is my syndrome 1, syndrome 2, syndrome 3, all the way to syndrome 7. Okay, but I have to be careful. Most of it is on the right, okay, but I mean for every other cases, okay, we use most significant bit on the left. Okay, so not to be confused, I put the syndrome table So this is my syndrome table here. My syndrome table has syndrome S. Most significant bit is on the left, okay, and least is on the right. My error pattern E also most significant is on the left and least significant on the right, okay. Okay, so when I wrote down in the table, I have to reverse the order, okay. This is the same 0 0 0, but this one, this is most significant, okay. So I have to put, instead of 1 0 0, I have to put 0 0 1 here because most significant is here, okay. And then this one becomes 0 1 0, this one become here 1 0 0, okay. This is 0 1 1 1 1 0 1 1 1 and 1 0 1, okay. So reverse the order inside the circuit, okay, of the result inside the circuit to make it the notation that we always use, okay. Now for the error pattern, we start with if no errors, okay, syndrome equal to 0, no errors, okay, so no errors, errors equal to all zeros. If you have 0 0 1, okay, as a syndrome pattern, then you get error in the first bit on the least significant bit here, and then the second bit, the third bit, like this until the end bit. This is as I told you before. If you want to know why, please ask later in class, okay, as they have to explain a little bit more to really understand what is going on, okay. But this is how to do it. Okay, now the method to correct single errors, okay, correcting steps, okay, using the syndrome table is done by first receiver receive the receive sequence R, it will compute the syndrome S. Syndrome can be computed 3 ways, okay. First is the modulo 2 addition, second is the polynomial, okay, and third is the chip register. Usually if by hand I use modulo 2 addition, okay, it's easier to do, okay. Anyway, then you find the syndrome, use the syndrome table to find the error values. What is the decoded code word? Decoded code word we had is the receive sequence plus the error sequence, okay. The receive can be what we send, okay, the code word plus the errors, right? Error can also be 0, but if you have errors and error is not 0, so we have V plus E is this is your R, okay, and then you plus E again, so it will cancel out, and then you get the V, which is the code word that you want, okay. Because you modulo 2 addition, if it's the same, it will be cancelled out. Now you will take the first the first k bit, okay, of vector V decoded code word, okay, as the decoded theta. Okay, look at example. Correct a single error. Given G equal to this and I equal to this, this is the same as last example, but I changed the third bit of R, okay, to be wrong, okay. But the receiver doesn't know this, okay. Again, this is most significant bit. Always, if I don't say anything, most significant on the left, okay. So we want to detect the error, we want to find the syndrome, okay, basically. So you find remainder of R divided by G, right? So you get this, and you get 1 1 1 1 1 0 1 1 1 0 0 0 1 0 1 1 1 1 0. Okay, so this is your syndrome. Yes, okay. So your syndrome is 1 1 0. Now you check the table. Okay, go back and check the table. 1 1 0 is this, okay. 1 0 is this. So error patterns is the third bit from the left, okay, or the third bit from the most significant bit. This is the error pattern. Okay, so go back here. Then we get syndrome table is this, error is this. So I put it most significant bit here on the left and the least significant bit on the right, okay, to clarify the position. Okay, so the decoded code word is R plus E. So this is R, this is E. So you get this. This is the same as the received sequence from the last example with no error. Okay, with syndrome equal to 0. So this is basically a code word. Okay, and decoded data is the same. Okay, so this is how you correct a single bit errors, okay, by hand. There are also the way that we done it by the circuit, okay, and so much more. Okay, so anyway, for the China coding topic, okay, which is quite long, I would like to stop here. Okay, and if you want to know more, okay, I actually giving away my books. Okay, this one, okay, you can ask, okay, if you want to get this book. But the second one, we don't have much more. Okay, I have only about 10 copies left. Okay, for the second one, so I'm not giving away anymore. Anyway, so thank you for your attention, and this is the end of the slide here.